It's important that you guys realize a couple things because we've been talking about angle relationships and now we have two different situations and we're going to be adding more today. So if it's the central angle is congruent to the intercepted arc. So don't forget, if you have a central angle, it's congruent to its intercepted arc. That's what we learned last week. If the angle's vertex sits on the circle, so if the angle's center or vertex sits on the circle, it is half the intercepted arc. So these are the two situations you have learned so far. We are going to be talking about kind of three more today. So we are going to be talking about three more of these today. So if it's a central angle, remember that it's just congruent to the arc. And the arc and the angle are congruent. If the angle's vertex sits on the circle, it's 1/2 the measure of the arc.
What's that?
All right. So we are going to continue on, but first we need to understand the vocabulary again. So the next slide we're going to run through pretty quickly because you guys should know what those are by now. And then it's going to get to that challenging point. Guys, make sure you're using your notes on your homework. Guys, we need to stop. Stop. No, you have not. Okay. Tell whether the line, ray, or segment is best described as a radius, chord, diameter, secant, or tangent. Okay. PK. Olivia, what would you call PK? Huh?
I don't even remember.
Look at it. You know what it is. It's half a circle. What is that called? It's the radius. So PK is the radius. What about segment NM? So it's just the segment part of NM there, Hunter. What would you call that? That's a chord because it stops at the circles, like on the circle. Okay, Morgan. What about ray? JL. It is tangent. It's hitting at one point on the circle. That is the point of tangency. Guys, stop talking. Helena, what is KN? KN is the circle all the way across. Sorry, Rob. All I hear is talking, so I didn't know that's what you were doing. NL is the actual, line, NL. What is line? NL, Hayden. It is a secant. It goes through the circle. It doesn't stop. That's not one of your options. And PN is a radius. Okay. So really quickly, just knowing what those are is important. Does anybody have questions on that? You need to know vocabulary. I don't know exactly if there's vocab on the quiz, but it's important to know that this is what's going to be on the quiz, like all this angle relationship stuff we've been doing the last 2 weeks.
I just meant if we have to know.
I will tell you tomorrow when we're reviewing. Yeah. Okay, tangent and intersected chord theorem. If a tangent and a chord intersect at a point on the circle, the measure of the angle formed is 1/2 the measure of the intercepted arc. This is the same thing as yesterday. If your vertex lies on the circle, it's going to be 1/2 the measure of the arc. Do you guys understand that? It just looks different because part of the angle might be outside. Do you guys see that? But if the vertex lies on the circle just like it did yesterday, remember when our vertex, when we did this yesterday, our vertex lied on, I can't even speak, was on the circle. Wasn't that the same relationship? Wasn't this the same thing we talked about yesterday? It was half the measure. If the vertex is on the circle, it is half the measure of the arc. If it's at the center, it's the same measure of the arc. So we have to remember these things. So let's look at this. We want the measure of angle 3. Is our vertex on the circle? It is. So we know that the measure of angle 3 is 1/2 the measure of its intercepted arc, which is this arc here. What is the degrees of that intercepted arc? How many degrees is that intercepted arc? 220. So we'll do half of 220. So the measure of angle 3 is 110 degrees. The second one is 100. We'll look and see. Okay, guys. How about you come and sit? I need you to just roll like a pillow, and you can create a little nice space, and you can just sit right in front of the room every day. Switch spots with me.
Yeah, switch spots with me.
Okay, literally, you used to take pictures, and now you're not even taking pictures.
I know.
You need to, Olivia. Switch spots with Ian, please.
No.
I might have to play musical chairs. Okay, so we are looking, guys. We need to find the measure of angle 6. Its intercepted arc is here, and it sits on the circle. So we know that the measure of angle 6 is going to be half of that arc. Do we know what that arc is, though?
No. Yes.
How could we find it, Kylie?
Because the other part of the circle is 160 and the whole circle goes 360, so you just subtract.
So 360 minus 160 is?
200.
So this is 200. So now can we find the measure of angle 6?
Oh,
Yes.
the 160. Never mind.
Are you sure?
Yeah, I didn't know where the 160 was.
Thank you for always asking questions, guys, when you're confused. I want you guys to understand what's going on here. So yes, so that is 200. So originally, it did not look like we could do this problem, but we realized it made a whole circle, which is 360 degrees, so we subtracted that. So we know that the measure of angle 6 is half of 200, which is 100 degrees. So again, think back to yesterday. If your vertex of your angle lies on the circle, then it's half the measure of the arc. So let's look at the next page. Is our vertex sitting on the circle? Is our vertex sitting on the circle? Yeah, so we can figure out what this arc measure is because we know that the measure of angle, I guess I'm going to call it, that's not even right though, so I'm going to call that D there. BAD is equal to 1/2 the measure of arc AB. That's not even named right, but that's okay. So what is the measure of BAD? Guys, so we know that the measure of the arc is 202 degrees. So arc AB is 202 degrees. Did we want that one, though? Is that the arc that they asked us to find? No. That's not because it's a major arc. So we can't use that one, yeah. What?
So the angles will go on the left side, and then the arcs will go on the right side. Is that how? I'm confused.
It depends on, I mean, you could technically write it either way, but how I always write it, I usually do put the angles on the left side and the arcs on the right side.
But like the half is always on with the arc, right? So
Correct. Yes. Okay, but the problem is that this is a major arc and it wants you to find a minor arc, right? So I should have had another letter here. I didn't know how big that was going to be. Bless you, so I can't use C again. So that should be an E. So really this should have been arc A, EB, right? Because it's a major arc. Do you guys see that? It's bigger than 180 degrees. Remember that major and minor arcs discussion we had? And major arcs were 3 letters. So that actually doesn't work for us. So we actually need to find this arc here. We need to actually find this one here, the minor arc. No, you don't even have to draw these points. I'm doing this for the notes.
Oh.
Yeah. So how can I find that arc there? How can I find arc AB then? Yeah.
Subtract 360 and 202 to get a number, and then
A number.
I don't remember.
What is that number?
Uh,
Is it 158? So the measure of arc AB is 158 degrees. So Casey, what I'm doing right now is trying to give you guys like an idea of where I'm getting things from. You can probably do some of this stuff in your head and not have to do that.
Okay.
So it's important you guys realize we are finding a minor arc because it's 2 letters and not a major arc, and 202 degrees is a major arc, so that's why we had to go through the other side. Again, is our vertex on the circle? Is the vertex on the circle? So we're going to keep that relationship here. We have this angle, and we have this one here. How can we find the gray arc? How can I find this gray arc? What can I do with the 129? What would I do with the 129 to find the measure of the gray arc? Multiply it by 2, right? Because the relationship is that the angle is half the arc. So if we multiply this by 2, we get our arc. Is it 258? Is that the arc they wanted us to find, though?
No.
No. So how can we find FH now?
Subtracted from 360.
It's 102, you said?
Yep.
So that is the measure of arc. FH is 102. Sorry, my answers are everywhere. Okay, last one there. What are we going to have to do first to be able to find the measure of angle 1? What are we going to have to do first? Who thinks they can figure this out? We've done a couple of these problems now. What will we do first? Greg?
Subtract 248 from 360.
So we can get this arc, right?
Yeah. And then subtract, or divide 112 by 2.
So this is 112 degrees. Good. And we know that the relationship is angle 1 is half 112, right? Half of the arc, which is, goes in there 5 times
56.
6. Okay. All right, so that is the same as it was yesterday. So if the vertex of the angle lies on the circle, half the arc measure. Is that what you kind of were asking earlier? Okay, things are going to change a little bit here, though. We have other situations. Things will change a little bit. So if the vertex lies on the circle, we take half of the arc. What if the vertex is at the center of the circle? What do we do? It's the whole thing, right? It's both of them. It's the same thing. So now we're going to talk about what happens if an X is created inside of the circle. So what happens if there is an X that is created inside of the circle, also known as vertical angles? So if 2 chords intersected inside a circle, then the measure of each angle is 1/2 the sum of the measures of the arcs intercepted by the angle and its vertical angle. So there's a lot going on here, isn't there? You have to memorize all this stuff, guys. It's a lot, isn't it? So if an X is created, what sign does it look like a little bit? Does it look more like addition or subtraction? Addition. Do you see what we're doing with the arcs? So think of that. An X is created. It kind of looks like an addition sign, all right? I'm kind of like, pulling at this a little bit, but it kind of looks like an addition sign. So that means we are going to literally, and then I'll answer your question, Casey, add DC and AB together and divide them by 2. Half them. And that gives you the angle measure. That would give you actually both of these angle measures here, so you guys know. So, Casey, what's your question?
But you're finding angle 1 and 2. What do you mean?
So, angle 2, you would have to use different arcs.
And are you solving for the 1 and the 2?
Yes, you're finding what the angles are.
Why don't you just do because on the actual examples it'll give you numbers. Why don't you just do that?
We are going to do numbers. This is just the
key.
the theorem. So it gives you just like in general, like this is what you would do.
What I'm saying is, why can't you do when it gives you the measure, say BC is 52, why can't you just divide that by 2 and then 2?
Divide it by 2 to get 2? Because do you see where the vertex of the angle is? It's no longer on the circle. You only divide by 2 if it's on the circle. Since the vertex of the angle is creating an X right now, you're going to have to average these 2 because it's intercepting 2 different arcs. So it's intercepting, technically because angle 1 and this angle are congruent, it's intercepting arc AB and arc DC, so you can't just half one of those arcs because it's not those are 2 different measures. So that's why we're adding them together to get the average of those arcs. Does that make sense?
Yeah.
Because the other ones are only intercepting 1 arc, and that's why we can just take half. Does that make a little bit more sense?
Yeah.
Okay. So let's try find the measure of angle 4 if FG is 88 and EH is 76. Do we know the arcs that angle 4 is even intercepting? No, but can we find the measure of angle 3? What is formed by the angle 3 and angle 4? What are those two? What do we call that?
A line.
A line, a linear pair. Good, a line. Close enough. I'm good with that. So, we know that the X in the middle kind of looks like an addition sign, right? So we know that we're going to add those arcs together. And what do we have to do after we add those arcs together? All of them are going to have a half except the central angle, just so you guys are aware. All right, even the next one. So the only one that doesn't have a half involved is the central angle, which is exactly the same anyways. So 8 and 6 is 14. So is that 164? Did I do that right? Anybody want to add that for me to make sure I'm not adding things wrong? It's right?
Yep.
Okay. Half of 164 is 82. So essentially you're just saying it's intercepting 2 different arcs, kind of what Casey was asking. So we don't have 1 arc we can take the half of. So that's why we have to average those arcs to figure out really what the measure is. And we don't know that that angle is at the center of the circle because there's no center dot too. So we have to be careful with that. All right, so you'll notice these ones have center dots in them. So are either of these central angles? No, but it's creating vertical angles or that X in the middle of the circle, which kind of looks like an addition sign. Yeah.
What was the measure of angle 4?
Oh, I didn't even do angle 4, did I? Sorry.
Yeah, it said to find angle 4.
And then I found 3. So angle 3 is 82 degrees. How can I find angle 4 then? We said that's a linear pair, so we'll do 180 minus 82, which is measure of angle 4 is 98 degrees. Sorry, guys. Thank you for correcting me. Got ahead of myself there. All right. So these both are creating X's, which look kind of like an addition sign. So to find the measure of angle 1, what are we going to do? Logan, what are we going to do to find the measure of angle 1?
40, 52.
And what do we still have to do with that? Yep. Take half of that. So that is half of 92, which is 46. So that actually gives us angle 1 because we have those two intercepted arcs. Will we get to angle 5 right away with this problem here? What are we going to have to find first? Are we going to have to find one of these angles first? And then find 50? And use the linear pair? So, I'm going to put a 1 in here. The measure of angle 1 equals what? Be careful. It's not just half of it because is that sitting on the circle? No, it's creating an x, which is an addition problem, which means you have to add these two arcs together, right? So 90 plus 130 times a half. In a second, I'm teaching. I'll bring some over in a second. So the measure of angle 1 is 60. But do I want the measure of angle 1? I'm actually going to do this right. Do I want the measure of angle 1? No, I do not. What do I want? I want the measure of angle 5. What can I do to get the measure of angle 5? Yeah. So we'll do 180 minus 60, which is 120 degrees. That's first.
Oh, and don't work at Culver's.
All right. Oh, that's not the measure of angle 1 that I wanted. Okay, next one. Here is the final, what?
I think you messed, I thought we messed up.
No.
Yeah. Measure 1.
Oh, that should be 220, right?
Yeah. 10.
Sorry, guys, I did mess up. Shh, please pay attention. So that's 210 here. I messed up. I had it wrong. So that's 220, which is 110. And then we'll do 110 minus 180. Or the other way, actually, which is what? 70. Sorry, guys. I know. It's like 300 degrees. Good thing I can't add. All right. Oops, sorry. So angles outside the circle. Angles outside the circle. If a tangent and a secant and two tangents or two secants intersect outside the circle, then the measure of the angle formed is half the subtraction of the intercepted arcs. So these two arcs are the intercepted arcs, and we are going to take half of them and subtract them this time. So there's 4 cases. Central angle means that the arc and the angle are the same. If that vertex point lies on the circle, then we know that the arc is what to the angle in the angle relationship. The arc, you take what to the arc? Half of the arc is the angle. We learned that if it's making an x inside, that vertex is inside making an x, we have to add the two arcs together and half them, right? So we have one more situation. What if that vertex is outside? You're going to basically do the same thing as last time. Do you see how it's intercepting two different arcs here? So you're going to have to subtract them and take half of them. Notice every single case has a 1/2 except the central angle. Do you guys all see that? The only one that does not have a 1/2 is the central angle, so don't forget that 1/2. So you always do the bigger arc minus the smaller arc to get the angle. So bigger minus smaller. Just make sure you realize that. Okay, so let's try these problems. On number 1 or in general? So, do you see how here's your angle? So it's these two arcs here.
Oh.
And then like this one actually intercepts the whole circle. And then this one, it's just this one and this one. Do you see that now?
Yeah.
Casey? Okay. So we need to find the angle. We have one of the intercepted arcs, but we don't know the measure of this other intercepted arc. Could we find the measure of that other intercepted arc? Could we find the measure of that arc? Yeah. We already have two of the angle measures, and there's 360 degrees in a circle. So far we have 204 degrees of the circle, right? So to get this angle, this arc, we'll do 360 minus 204. So this arc here is 156. So the vertex is outside the circle. So we are going to subtract these two and multiply them by 1/2. We always do bigger minus smaller. So 156 minus 60. Half of that equals the measure of angle x. Or I'll just put x. It doesn't have to say angle x. So is that 90, what?
No.
What's 60? Is that 94? That doesn't seem right. Did I do that right? Do 156 minus 60 for me. Is it?
96.
It's 96? Okay. That doesn't, did I say 60 or 50?
156 minus 60.
Okay, sorry. Okay, half of 96 is 48, I think, right? Mm-hmm.
48.
Okay, let's try this again. This time it wants x. Is x the bigger or the smaller arc? The smaller one. So we are going to have to do 1/2 of 141 minus x is 62 degrees. The easiest way to solve this is to multiply by 2 first to get rid of that fraction. Is it 17? Can somebody do that for me? Can somebody do 124 minus 141?
17.
It is negative 17, so x is 17. Okay, this is challenging, I know. We are reviewing tomorrow. I can go over lots of homework questions tomorrow. Okay, last page. We're going to kind of fly through this. I'm sorry. We don't have a lot of time. Oops, I didn't mean to do that. All right. So these are all algebraic here. So we are going to do 1/2 of 5x minus 63 equals x. So the first thing we'll do is multiply by 2. So that gives me 5x minus 63 equals 2x. So negative 63 equals negative 3x. So x is 21. Okay, this next one is really challenging, so you have to remember to distribute. So we need to do 1/2 of the bigger arc, which is 17x plus 6, minus the whole entire 7x minus 2, equals 39. So I'm going to multiply both sides by 2. This one is 17x plus 6, and the other one is 7x minus 2. So that's 78. Then we have to distribute the negative through, so we can switch it to a positive, so that's negative positive. So I get 10x plus 8 equals 78. So all I did here, guys, is I said this was negative, right? Which means that switches the signs of everything in here, so I can change it to addition, right? So a positive becomes a negative. A negative becomes a, and then I just add it like terms. So 17 minus 7x is 10x. 6 plus 2 is 8. So then I get 10x equals 70. So x equals 7. Okay, last one. Do you guys see how these two arcs form a whole entire circle? Do you guys see that? So this is going to be represented as 360 minus x because we're taking that and taking it away. So we're subtracting the x from 360. So we'll do 1/2 of x minus 360 minus x equals, is that 37? Yeah. So we multiply by 2. And then we're going to distribute, which means it switches to positive and switches our signs. So again, this is the whole entire circle. Do you see how both arcs make the whole circle? So if this is x, this is subtracting 360 minus x, which means that we have to subtract it. So I distributed that through. So I get 2x minus 360 equals 74. So I add 360 to both sides. Is 434. Divided by 2. That does not, maybe that does. Okay, so let me